Introduction to Numpy. So this section along with the next section outlines techniques for effectively loading, storing, and manipulating in-memory data in Python. The topic is very broad, thus datasets can come from a wide range of sources and a wide range of formats, which includes collections of documents, collection of images, collections of sound clips, collections of numerical measurements, or nearly anything else. Despite this apparent heterogeneity, it will help us to think of all data fundamentally as arrays of numbers. So here we have an example, which I will quote here, that for example, images, particularly digital images, can be thought of as simply two-dimensional arrays of numbers representing pixel brightness across the area. Sound clips can be thought of as one-dimensional arrays of intensity versus time. Texts can be converted in various ways into numerical representations, perhaps binary digits representing the frequency of certain words or pairs of words. No matter what the data are, the first step in making them analyzable will be to transform them into arrays of numbers. Okay, so for this reason, efficient storage and manipulation of numerical arrays is absolutely fundamental to the process of doing data science. We will now take a look at the specialized tools that Python has for handling such numerical arrays, which is the Numpy package and the pandas package. This section will cover Numpy in detail. Numpy, which is a short form for numerical Python, provides an efficient interface to store and operate on dense data buffers. In some ways, Numpy arrays are like Python's built-in list type, but Numpy arrays provide much more efficient storage and data operations as the arrays grow larger and larger in size. Numpy arrays form the core of nearly the entire ecosystem of data science tools in Python. So time spent learning to use Numpy effectively will be valuable no matter what aspect of data science interests you. So if you followed the advice I outlined before and installed the Anaconda stack, you already have Numpy installed and ready to go. If you are more to do it yourself, you can go to the Numpy website and follow the installation instructions found there. Once you do, you can import Numpy and double check the version as we can see here. So starting off our first code, it is import Numpy. But now that means Numpy has been installed, but import Numpy. We want to check the version of the Numpy, which is 1.15.4. So for the pieces of the package discussed here, I'd recommend Numpy version 1.8 or later. By convention, you will find that most people in the SciPy or PyData world will import Numpy using np as an alias. So here we will use import Numpy as np. So throughout this section and indeed the rest of the course, you'll find that this is the way we will import and use Numpy.